Dia dulu. Hai, Assalamualaikum dan selamat petang semua. Okay, today we continue revision on chapter 4, Electromagnetism. Okay, so let's look at the paper 1. There are 11 questions from this paper 1. Okay, diagram 1 shows left hand, okay, which represent Fleming's left hand rule. Okay, for this Fleming left hand rule, FBI. Okay, so the F represent the motion or force, direction of force. B is magnetic field direction, always pointing to south, north to south. And then current. The physical quantity represented by X. X is magnetic field. Okay, so the answer will be C. Number 2, direction of magnetic field for straight conductor can be determined by for a straight conductor like this. Let's say we have a straight conductor. Okay. When current flow this direction, okay, there will be magnetic field around the wire. Concentric circle. Bentuk circle. Direction determined by either is clockwise or anti-clockwise, determined by right hand grip rule. Okay, you can see your thumb. Okay, and then you got 4 finger. Okay, the 4 finger. So the thumb here represent the current, and the curl of the other 4 fingers represent direction of current. So we put this way, you can see it will flow or direction of magnetic field will be in the direction which is anti-clockwise direction. Okay, so this one is known as right hand grip rule. Okay, number 3, diagram 2 shows simple electric motor. When the switch is on, it results catapult field and turns the coil. Concept. What is the concept involved for this one? Force on current carrying conductor in magnetic field. All the related rule that we can use to determine direction of motion of the conductor is Fleming left hand rule. Okay, electric motor consists of permanent magnet, coil, commutator, carbon brush, and external circuit. Which of the following show the correct magnetic field pattern? Okay, let's say the switch is on. Current flow from positive to negative. Okay, flow to A in this direction. If you apply Fleming left hand rule for A, part A, the force will be downward, and the other one opposite direction, which is upwards. So this one, the cause direction of the rotation will be anti-clockwise direction. So if direction of this side is downward, meaning above is strong, below is weak. Same thing here, if moving up, below is strong, above weak. Okay, if we try to draw the catapult field, this is north, south. For A is current in, we can draw it cross. For D, current is out, so you can draw it dot. Okay, so direction of the magnetic field or magnetic force is downward, means above is strong, below is weak. Strong, weak. So same thing here, weak, strong. Okay, so we draw the catapult field, we get like this. Draw the strong part first. Means more line will go to the strong part. The rest you just add. Okay, so you will get this one, direction of force will be downward. Here is upwards. Okay, so which one is correct? You can check. Okay, so answer will be D dan D. Okay, number 4, diagram below shows copper wire placed dipole of magnet PQ. Dia tak berikan dia punya pole apa, PQ. Motion of copper wire out or to the right, you can say it's to the right. Okay, mark direction of current, positive to negative. Yeah, because this one is plastic, so no current flow here. Okay, so you go down here. So the current is into the screen. Okay, direction of F is to the right. So this question want you to find the pole for P and Q. Apply Fleming left hand. So you put direction of the magnet to the right, current into the screen. So you will get the force, you can get into the force is to the right, current into the screen. You can see your forefinger is pointing up. Pointing up means up is south. So I hope you can imagine this one. It's just like using your finger, 3 finger, 4 finger, and then this one is your thumb. Okay, so this is the current, this is the force, and this one will be the sorry, my mistake. Wait, I draw it wrongly. This is the current, and then this is your 4 finger. This one is your thumb. Okay, so current, ini 4 finger. Okay, and then this is your thumb. Normally is FBI. Okay, FBI. Your thumb, your 4 finger, and middle finger. Okay, so middle finger is for current into the screen. The 4 finger upwards, meaning upward is south, and then this one is for the motion ataupun force. Okay, so you dapat P ialah south, Q ialah north. So you dapat jawapan B boy. Okay, diagram 5. Part of arrangement of the apparatus used to study factors affect magnitude of force using current carrying conductor in magnetic field. Based on diagram, explain how to increase distance of motion. Distance of motion is affected by magnitude of force. Means the stronger the force, the longer the distance of motion. So what are the factors that affect? You can see from the FBI, Fleming right hand rule. So there is a factor of magnetic field and factor of current. Okay, so it means if you want to increase the force in order to increase the distance move, so you must increase the current, you must increase strength of magnetic field. Increase distance no, because it will make the magnetic field lines or the magnetic field strength become weak. Increase number of magnet, yes. Increase the strength, so you have 1, 2, 4. Okay, answer will be D, donkey. Okay, again, Number 6, diagram 5 shows the conductor move horizontally in between 2 permanent magnets. You can see there's no battery, no power supply. So this is not the concept of motor anymore, ataupun not a concept of force on current carrying conductor magnetic field, but this one is about induction. Okay, this topic, no battery, no power supply. This is already topic of induction. What is induction? Production of current due to change in magnetic flux. Means there is a cutting off magnetic field lines. So this one will produce induced EMF or induced current. What will happen to the pointer of galvanometer? Okay, if the conductor is moved horizontally, this is the magnetic field lines. Let's say this direction. If move the wire horizontally, it will cause it to become parallel. F and B are parallel. If parallel, there will be no induction occur. Kenapa tak ada induction? No cutting off. Tak boleh potong. Like you are using a knife, try to cut at the surface, but you move it parallel to the surface. Of course, you cannot cut, okay, the object. Okay, so you must move it at certain angle or maximum at 90 degrees. Then only you can cut the surface. Okay, so this one no cutting off. Okay, so no cutting off means no deflection. No cutting off ataupun no induction occur. Tidak berlaku induction. Okay. Number 7, an ideal transformer. Ideal transformer means efficiency 100%. This is a symbol for efficiency. Ya. Itu maksud ideal. Power output equals to power input. What is potential difference across the bulb? This one to relate between V and N. So you have Vp over Np, Vs over Ns. You want to find Vs. So it's Vp, Np, Ns. Vp here, from here, the one with power supply, AC power supply, this one will be Vp, and across the bulb will be Vs. And 110 here is Np, 2510 is Ns. Okay, so you get Vs is 60 volt. Okay, number 8, Rosman charged his notebook computer using battery charger. Charger has transformer in diagram 7. Primary 12,000, secondary here. Okay, input 240. What is number of turns of secondary coil? So this is Vs, and this one will be Vp. This is Np. You want to find Ns. Vp over Np, Vs over Ns. So Vs equals to Vp 240 divided by Np 12,000 times 20. Sorry, saya salah sekejap. We want to find Ns, not Vs. Vs is already given. So Vs is 20, Np is 12,000, divided by Vp. before. Okay, number 9, system or transmission of electricity. Normally close to the power station, this is step down, and the rest all step up. Sorry. Step down, step up. The rest all step up. Okay, because let's say here produce only 33 kilovolt. So you step up, increase it to 103 kilovolt. Okay, transmit high voltage will reduce current and reduce energy loss as heat energy. Close to your house, of course, step down again because your house maybe just require about 240 volt. Okay, so P is step up transformer. So transformer P is used to increase voltage or increase potential difference. See. Okay, number 10, a bar magnet being pulled away from the lens from a solenoid. So ini ialah Lenz's law. Okay, you move north pole away from this end will become opposite pole, will become south. So it will try to attract the bar magnet again. So that one we call it opposite effect. If this one is south, this one will be north. Apply right hand grip rule for solenoid. Your thumb will pointing to north. So means the forefinger curl upwards. Curl upward means like this. Okay, then go down here, down here. Okay, soalan. Direction of deflection galvanometer pointer can be determined by Lenz's law. Okay, this case is Lenz's law. Okay, so why the pointer deflect to the right? It follow the direction of current in the solenoid. Okay, you can see solenoid is from left to right. So when left to right, the pointer will be deflected to right. Okay, ke kanan. Okay, number 11. Diagram below shows a bar magnet released from different heights. Different height will cause difference in the final velocity. Okay. Okay, the higher the height release, the higher the final velocity. Okay. Based on diagram, which statement is true? Okay, as we know that the factor of velocity is also factor that affects magnitude of current, or we can say deflection, deflection of the pointer. Okay, look at A, which one is correct? Height of bar magnet release, deflection decrease. Wrong. Kalau ini increase, okay, induction of induced current increase. Deflection is more, so we can see clearly B is correct. Look at C. High or bar magnet decrease, cutting off magnetic flux increase. High or bar magnet really increase, cutting magnetic flux decrease. So wrong. Ini soalan analisis. You need to apply what you know about the concept of induction. Okay. And then find which one is the most accurate one. Okay, so B is the answer. Height increase, deflection increase because induced current increase. So this topic actually discuss about two concepts. The first one is force on current carrying conductor. In magnetic field. Okay, here you can see application of right hand grip rule. Then we have Fleming's left hand rule. Then the concept of electromagnetic induction. Okay, so this one induction. So kita ada konsep Planck's law, Faraday's law, this one apply Fleming. Okay, section A. Number 1. Diagram 1 shows handphone battery charger connected to 240 volt AC power supply. The battery charger contains box X and box Y. The function of component in box X to lower the voltage. Name component X. If you know the symbol, the electrical symbol, I think you know the name of X. That one is symbol for transformer. You can see boleh nampak ini dia ada 240 volt, ini bahagian primary, secondary. So ini ialah dia punya iron core. Okay, so X actually is transformer. Transformer used to increase or decrease voltage of AC. So name the component in box X, transformer. 1 mark. State the physics concept. Explain how component in box X works. Okay, how it works? It based on principle. Concept atau principle ialah force. Electromagnetic. induction. induction. Okay, there's a calculation problem, 2 marks. Number of turns of primary given, look at diagram. Primary voltage given 240 volt. Number of turns of primary 960. Step down to 220 volt. This one will be yes. Okay, so just use this formula ni. You get an S equals to 80. Okay, part C, efficiency of component 80%. Calculate input current. Input current is IP. Output power PO 65 watt. Okay, from above you already given VP 240 volt. NP also given 960. Formula efficiency. Power output over power input times 100%. So you will get input 65 divided by power input times 100% equals 80%. Okay, power input is IP VP. VP already have given, VP ialah 240. So 65 over IP VP 240 equals 0.8. I'm bringing it here. So IP equals 65, 0.8, 240. Okay, so you will get the answer 0.34 ampere. So this is the primary current. Input current means primary current. Question number 2. Diagram 5.1 and 5.2. Number 2. 2.1 and 2.2, identical copper rod placed on bare copper wire in magnetic field. Okay, so you can see there is a dry cell here, ada power supply. So konsep ialah force on current carrying conductor in magnetic field. This is the copper rod. This is bare copper wire, ammeter. Okay, soalan. When the switch is closed, pointer of ammeter deflects and copper rod move to the final position. What is the meaning of magnetic field? So ini definition, just write down definition. The region when magnetic particle or magnetic substance experience magnetic force. Okay, the region where magnetic material, ferromagnetic, something like anything that attracted to a magnet. Okay, magnetic material experience magnetic force. Means it will experience either repel or attract. So kawasan tu kita panggil magnetic field. Okay, B, compare number of dry cell used between the two diagrams here. So you can see. So dry cell here 3 dry cell, ini 2 dry cell. So 2.1, 2.2, 3. Don't mention the number, just compare something like this. Number of dry cell in 2.1 is smaller than in 2.2. Okay. Compare angle of deflection. Okay, angle of deflection ataupun actually is, you can look at here. This is the deflection. Angle dia ni. Ini angle dia. Okay. Ini second one. Okay, you can see this is the angle. Okay. So angle of deflection in 2.1 also smaller. Angle of deflection in 2.1 is smaller than in 2.2. Okay. Then part 3, compare final position. So the final position, you can compare something like which one is further or closer. Okay. So for this one, the copper rod in 2.1, okay, the final position of copper rod in 2.1 is closer to the ataupun smaller pun. Then in 2.2. State a physical quantity that caused the rod to move. Anything that can move object, we call it force. Just write down force. Relate number of dry cell and magnitude of electric current flow. You can see in diagram 2, more number of battery means the current flow is larger. As you can see from here, the final position in 2.2 also is larger. So it means the larger the current, the further the distance of the copper rod move. Or we can say the greater ataupun the smaller pun boleh, the greater the number of dry cell, the greater the magnitude of current flow. Okay. Relate magnitude of current flow and magnitude of physical quantities stated in 2C means current and force. The greater the current, the greater the force. Name the rule used to determine direction of movement of copper rod. This one, direction, can be determined by Fleming's left-hand rule. F, state another one way that can move the rod further. Okay, back to the FDI, factor that affect force, we have magnetic field and current. Okay, so the current is already discussed in this question, but it does not discuss about magnetic field. So mean the other factor is magnetic field. If you want to increase the distance of the rod move to make it further, means you need to increase the strength of magnetic field. How to increase the strength? You can use stronger magnet. Okay. Or increase the strength of magnet. Or using larger size of magnet also can. Okay, number 3, diagram 3.1, 3.2 show deflection of galvanometer when bar magnet push into two identical solenoid. 3.1, 3.2. If you check the difference between the two diagrams, you can see different in number of magnet. First diagram only use one magnet. Second diagram use two magnet. Okay, what else the difference? Same number of turns of solenoid, but deflection of pointer angle is different. Smaller angle of deflection. This one larger angle of deflection. Okay, next question. Underline the correct answer in the bracket to complete the answer below. method of producing electricity without electrical supply is known as electromagnetic induction. No need power supply, no need battery, but by cutting off magnetic field lines, it will produce induced current or induced EMF. So means by motion. Okay, by motion produce current. B, state magnetic pole at B when bar magnet push into solenoid. Okay, north pole if move towards NB, move towards, it will produce repel force according to Lenz's law. To produce effect which is repel force, it will become same pole. Okay, move towards same pole. So NB will become north pole. Okay, part C1, compare number of bar magnet. Okay, number of bar magnet in 3.1 is smaller than in 3.2. Don't write number of bar magnet in 3.1 is 1, number of bar magnet in 3.2 is 2. That one is not comparison. That one you are stating what you observe in the diagram. Okay, part 2, compare angle of deflection. So you can see angle of deflection in 3.1 is smaller. Okay, then in 3.2. Compare number of turns of solenoid, same number of turns. Okay, same number of turns. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, same. Okay, so number of turns solenoid in 3.1, 3.2 are equal ataupun same pun boleh. Okay, part D, state relationship between number of bond magnet and strength of magnetic field. The larger the number of bond magnet, is stronger. Pada higher boleh strength of magnetic field the larger the angle of reflection. Okay. Name the physics law involved. This law is about magnitude of induced current. We asked another one way the increased angle of refraction of galvanometer. Ini ialah induction, so kita kena guna Fleming right hand rule. Sama juga FBI. Okay, force, magnetic field, induced current. Increase angle of diffraction meaning increase current. So solenoid. The increased number of turn means more cutting off, more induced current. Okay, number 4 ialah transformer WXYZ. Boleh nampak ini panggil center tap. Okay, transformer. Cara nak sambung, kalau you nak 500, you boleh sambung W dengan Y. Ataupun kalau nak yang 500 di bawah ni, boleh sambung Z dengan Y. If you want it to become 1000, so you just connect W and Z. State physics concept used to produce voltage across secondary coil of transformer. Ini soalan sama. Electromagnetic induction. Okay. State two pairs of output terminal that can be used when transformer is used to step up voltage. Okay, to produce largest output voltage means maximum number of turns. You can sambung W and Z. So you will get W and Z is 1000 turns. Okay. So you boleh suggest point W and Z. Another one is X and Z. Okay, which pair of output will give largest output voltage? Ini bahagian C, W and Z sebab maximum number of turns 1000. Bahagian D, AC generator. So generator dia apply konsep induction. So boleh tengok sini, there's no power supply, there's no battery inside, only one bulb. Okay, there are characteristics of three alternating current generators. Kita ada P, Q, R. Okay, soalan. Based on table 1, state suitable characteristic of AC generator which can produce more current and brighter bulb. Give reason for suitability of the characteristic. Okay, number of turns of coil. You want to make it brighter means increase more induced current. Okay, increase more induced current means you need to increase the number of turns. So tulis sini more number of turns. Soalan ni macam soalan section B. Dia nak you pilih. Okay, so dari sini actually you boleh pilih dulu. Number of turns of coil more. Jadi boleh ambil 2, remove lah yang ni. Shape of magnet, flat, curve. So is more to curve. Okay, so jawapan dia kita boleh nampak dah Q. Okay, reason more number of turns. Increase rate of cutting of magnetic flux. Ataupun produce larger change in magnetic flux also can. both can. The shape of permanent magnet is curved. Okay, reason reproduce radial and uniform magnetic flux. Okay, means the magnet is like this outside. Bulat. Macam tu. So dia ada tengah dia adalah okay, the coil okay, around let's say iron core, so it will rotate inside. So this one will produce something like radial. Radial is more like this, so it cannot be like this. So actually I just want to show you all. It's more to like this curve. Curve this part, and then the other one is curve this one. Curve. Okay. Okay, based on your answer, choose most suitable. Just now is B. Okay, number 5, this is DC motor. You can see DC motor because there's a commutator and there is a battery. So this one is motor. If no battery, that one will become generator. Okay, so this is motor, electric motor. What is the meaning of magnetic field? Sama soalan tadi ya. The region where ferromagnetic material or magnetic material experience magnetic force. Okay. To just memorize saja. Okay, B, cross-sectional view of coil magnet of DC motor. In diagram 5.2, draw resultant magnetic field that causes coil to rotate. Show direction of force that acts on the coil. Okay, go back to original direction. Tengok current, tanda current dulu. From positive to negative. So means for this side, current is in. For this side, current is out. North to south. Okay, then have this one. Okay, use Fleming left-hand rule to determine direction of force. Left hand, motor. Okay, so you will get this one force is upwards. This one is force downward. So if this one is forced upward, means below is strong, above is weak. Force downward means above is strong, below is weak. Okay. So now draw the strong part first. More line will go to the strong part. The field line cannot cross. Okay. Direction north to south. The rest we just add some more. Okay, so this is the catapult field for the electric motor. But see, modification needs to be done to make motor turn faster. state modification and give reason for your answer. FBI, climbing left-hand row, turn faster means force is larger. So how to increase the force? Increase current, increase the strength of magnetic field. To increase the current, number of battery must be more. Ataupun you boleh tulis juga increase the number of battery. Boleh juga. Reason, increase current. Okay. Number of coil, increase number of turns of coil. Okay. Increase strength of magnetic flux. Okay, shape of magnet. Increase number of turns of coil, increase strength of magnetic flux around the conductor. Don't get confused. Shape of magnet will be curve shape. Okay, same thing. Reason to produce radial magnetic flux. Magnetic field. Radial will be uniform and stronger. Okay, section B. One shows bulb level 12 volt, 24 watt connected to the output of transformer, efficiency 90%. This is primary. Okay, this is secondary. Type of transformer, we need NP and S. NP is more than NS, so means step down transformer. Explain working principle, ini soalan konsep, formal. Konsep kita akan gunakan ialah force on current carrying conductor in magnetic field. Induction, electromagnetic induction. Transformer, sorry. Electromagnetic induction, transformer. The first sentence is about when switch is on from the primary current here, primary, the AC current flow from primary circuit the direction AC current always changing. Always change. When direction always change means the magnetic field lines that produce in the coil also keep changing. So this one will produce change in magnetic flux. The change in the direction of current produce change in magnetic flux. Okay, now you can add in the law if you want, something like, according to Faraday's law, induced EMF in secondary coil is produced in secondary coil. Current flow and the bulbs lights up. Okay, for marks. Change in the direction of current produce change in magnetic flux. Change in magnetic flux produce induced EMF or induced current flow. For mark soalan konsep. Part B, there's a calculation 5 marks. Current flow in the secondary circuit, power input in the primary circuit. Here we have 12 volt, 24 watt. PS maksudnya IS, IDS ataupun PO output. So ini ialah 24, IS ini 12. So IS equal is 2 ampere. Okay, part 2. Given efficiency 90%. So means power input, our power input times 100% equals to 90%. Power output 24, power input equals 0.9. So power input 24 divided 0.9, so we get 26.67 watt. So power input is 26.67 watt. Part C, diagram shows 4 electric motor. Given diagram, so you just compare between the diagram, which one is suitable. Question: most suitable electric motor to produce greater speed. So you must know the factor that affect speed of rotation. Meaning ialah formula FBI tadi. You want to increase force, meaning greater speed. Strength of magnet increase, current also increase. Okay, we look at the specification. We have shape of magnet, type of core, number of turns of coil, number of dry cell. Okay, you can use table form. Aspect, characteristic, and then dia punya explanation atau reason. Okay, write down all the aspects. First, shape of magnet. Characteristic and curve. Material of iron core. Tiga, number of turns of coil. Then we have the fourth one is number of dry cell. Kalau you nak increase force, maksudnya kena increase dia punya strength of magnet dan juga current. Okay. Shape of magnet mesti curve sebab kita nak hasilkan radial magnetic field. Okay, material of iron core, kita guna soft iron core. Remember how to increase the efficiency of transformer, how to reduce energy loss and so all that. So you can apply di sini ya. So for soft iron core, easily magnetize and demagnetize. Okay, number of turns is more number of turns. Okay, stronger magnetic field around the coil. Number of dry cell is more to supply more current. Okay. So which one is chosen? So from here, If you look at the structure, the first one, the magnet is not curved, plain, using steel core, also the one. Riser one only. Okay, ini curve, but still we don't want only one saja. Okay, plain pula tak mau, soft iron boleh, riser more. Okay. Okay, ni nampak curve magnet. Okay, soft iron core, more number of riser. Okay, can see from here Z should be your choice. So write down Z is chosen because okay, salin balik daripada kolom ini ataupun dari table tadi ya. Okay, bahagian C. Position of magnet before being released into the identical coil. Different height meaning different final velocity. Means for the second diagram, this one will fall and reach the solenoid at higher speed compared to the first one. Kita nampak ini ya. Kalau yang short punya height, angle of deflection smaller. Kalau the higher, angle of deflection is larger. Induction, still on the topic of induction. What is the meaning of induced current? The current that produced by the current that produced due to cutting off ataupun change magnetic flux. Okay, ataupun by changing pun boleh. The current that produced by changing of magnetic flux pun boleh. Observe diagram 1.1, 1.2. Compare height of magnet release and size of deflection. Okay, dua markah Okay, the height of magnet release in 1.2 is higher than 1.1. Okay, the size of deflection in 1.2 is larger than in 1.1. Okay. State relationship between height of magnet release and velocity of magnet when enters the coil. The higher the height, the higher the velocity. Okay, lagi tinggi, lagi laju dia sampai ke bawah. Okay, yang ketiga, height of magnet release and size of deflection. Sama juga, the higher the height, the larger the size of deflection. Okay. And then velocity of magnet and magnitude of induced current when enters the coil. The higher the velocity higher the induced current. Okay. Part D. Explain how dynamo works. So induction. Tajuk induction ni antara topik popular yang keluar dalam trial exam negeri-negeri. Kalau you all ada buat latihan, you boleh nampak. Okay. Explain how dynamo works. Boleh nampak sini ada knob. Okay, once the wheel rotates, when you cycle the bicycle, it will cause the knob here to turn. When knob turn, it will turn the magnet. Okay, the magnet which is placed in the coil or wire. So this one will cause magnetic flux to be cut off. And induced current will flow in the coil. Okay, the wire is connected to the bulb. So this one will cause bulb to light up. Bulb akan menyala. Okay, so you can write in 4 sentences. First, the wheel turns the knob. Or the bicycle wheel or bicycle tire. The magnet rotates. What happens next? The magnetic field is tight. Then what happens? Induced current is produced. Induced current flow. Okay, so once induced current flow, the bulb will light up. This one is step-up transformer. You need primary, you need secondary. Okay. You are required to modify step-up transformer to a step-down. Explain modification need to be done to change it into more efficient transformer. In your explanation, emphasize aspect. Okay, dah ada 4 aspek given. You hanya tambah 1. Okay, satu lagi. Bagaimana nak tambah? Ataupun one of the aspect must give 2 idea. Okay, so try to answer for this one. Buat kolom juga. Okay, first aspect. Boleh salin dulu semua aspek sini. First, second, third, fourth. mesti ada 5, saya kurang-kurang. Kalau kurang tak cukup lah markah. Aspek dia je salin balik je. Way of winding, primary and secondary. Okay, nampak tak? Dia boleh buat 3 kolam. Untuk bahagian suggestion tu boleh besarkan sikit. Ya, saya besarkan sikit. Nanti nak tuliskan tak? Kalau nak buat 2 kolom pun boleh, tak masalah. Ini suggestion je, boleh cara sendiri. Boleh buat sentence pun tak apa, kalau cukup lengkap semua. Okay, suggestion, number of turns of coin. So, boleh masukkan kita nak modify kepada step down transformer kan, arahan soalan. More efficient to step down transformer. Jadi number of coil dia, number of turns of coil primary is more than secondary. That's why kalau tulisan panjang, besarkan sikit kolom ni lah. Okay, supaya dia dapat sama dengan number yang saya tulis ni. Okay, saya tulis ke bawah sikit lah. Wire boleh bagi banyak idea kat sini. Wire boleh letak low resistance punya wire, atau thicker wire pun boleh. Thick wire, low resistance. Okay, material of core, soft iron core. Tadilah reason tadi ya, easily magnetize and demagnetize. Okay, structure of core should be laminated iron core. Reason boleh dapat increase resistance of core, atau reduce eddy current pun boleh. Okay, way of binding primary and secondary. Wind secondary coil, lilitkan secondary on top of primary. Contoh macam ni ya. Kalau structure biasa dia macam ni. Okay, ini primary, ini secondary. So boleh nampak flux line dia akan leak out. Kalau wind on top, maksudnya boleh buat macam ni. Okay, mula-mula wind dulu yang primary, and then on top dia wind lagi sekali ialah secondary. Jadi maksudnya secondary on top of primary. So no chance the flux linkage tu akan leak out. Dia automatic akan link to the secondary coil. So yang ni akan dapat reduce flux leakage. Tinggal satu kat atas, sorry. Number of turns of coil is in primary is more than secondary. So to decrease output voltage atau secondary voltage, maksudnya function as step down transformer. Jangan tulis to produce step down transformer, itu repeat yang dia bagi di atas, so tak dapat markah. Tulis je to decrease output voltage. Okay. So itu antara soalan untuk tajuk electromagnetism. Jadi antara spot soalan ialah untuk essay section B dan section C ialah tajuk electromagnetism. Sama ada tajuk keluar electric motor, generator, transformer, macam tadi dynamo, semua tu yang apply konsep fizik yang penting dalam tajuk electromagnetism. Kalau first ialah berkaitan force on current-carrying conductor in magnetic field, second ialah electromagnetic induction. Okay. So I think that's all. Kalau ada soalan boleh tanya, apa-apa nak tanya boleh tanya sebelum saya end. Sudah panjang, dekat hampir 2 jam. Kalau ada soalan boleh tanya. Ada apa soalan tak? Okay, kalau you nak dapatkan jawapan, boleh dapatkan daripada tiket to victory daripada Anjung Ilmu Jpn Perak. Okay, kalau tak ada soalan, saya endkan session saya. Okay, thank you for joining my session today. Bye.